come to the Vintage Computer Festival at the Enter Museum to see the evolution of From the Hole to the Cloud.
Hi everyone, thanks for joining us today. Today we will talk about developing a game for PSP, and we will focus more on how it can be done today in 2025. That's why we called our presentation Developing with the Modern Tools. Yeah. So my name is Dmitrii, and this is Ivan. We both work as software engineers. We both work as software engineers, and building games for PSPs is just our hobby. This talk is not going to be a very technical deep dive into development games for PSPs, but rather serve as an inspiration for others to try. It's not hard today, and you will see why. So here's the QR code for this presentation for those of you who would like to follow the presentation on their own devices. And we numbered every page to reference in the Q&A section. So yeah, at the beginning of my career, I worked as a game developer, and I worked in very small game development studios. Together with my friends, we created our own game developing studio, and we failed to make it profitable and moved on to other opportunities. But around this time, we decided to start to join Liūtų Dare contest, and it's a game jam when people are required to create a game in 2 or 3 days for the given theme. And there are two main parts of Liūtų Dare contest. They are compo and jam. In compo, people participate individually, and in jam, they participate in teams. And when you are participating in a team, you need to create a game in 3 days, not in 2. That makes a lot of sense, right? Yeah. So that's actually answers to your question why it's so strange. It's for Liūtų Dare contest. It should be strange. So yeah, Liūtų Dare contest is very short. It's 2 or 3 days, and we participate as a team, and it's 3 days for us. So games for Liūtų Dare are usually not that very complicated. There are always some exceptions, like every contest has some exceptions, so you can see 1 or 2 games that are 3D, but majority of them are in 2D. So here you can see screenshots from our entries, not from every entry, but the most beautiful ones. I placed our first game here, and it's actually me. Yeah, in the past we developed games targeting personal computers, macOS and Windows platforms, and it was okay in the past. So we started in 2013. So it was okay. But now the security of a new operating system growing and growing and growing, and now it's really hard to make people to run your game on the PCs, because for example for macOS and for Windows we do assign binaries, and on macOS you need to first launch the game, then go to settings, find security and privacy settings, okay, allow like everything, then launch a game again, and it will ask again, are you sure? It's so scary. So it's really hard to make people to run your game if it's be built natively for PCs. But it was a well-established process for us. We used our own game development engine, and there were no surprises. And we needed a change. So 2 years ago, we decided to challenge ourselves and develop for Playdate. So there will be a really interesting talk after our talk here in this room about Playdate. So I think that I think that it will be very interesting. So we decided to pick Playdate as our target platform. But by the time, not that many Playdates were sold, but it doesn't mean that we reduces our chances for being played, for people to play our game. Because the ecosystem provides a really nice simulator, which is available for macOS, Windows, and Linux. Yeah, Linux too. So people can use this very trusted simulator, signed, everything is okay, and run our game on their own PCs. So it went quite well. We got enough players, we got enough ratings, and there was even one person who ran our game on a real hardware. So we read this in the comments. It was really nice. Yeah. So yeah, this is how this game looks like. Playdate has a monochrome screen, so no surprises. There are no colors. And yeah, we developed this game in the public GitHub repository. So if you want to see the code, you can. Yeah, and this year we decided to challenge ourselves even more and to develop a game for PlayStation Portable. Yeah. Actually, now there are tons of different ways how people can run your game that is developed for PSP. They can run on real hardware, and there are tons of PSP sold since 2004. So for example, this one is 20 years old, and this is my own device, and it's in pretty good condition, right? They can use emulator and run the game on the PCs. They can use emulator and run the games, the PSP game on their mobile phones. They can use emulator and run the game on Steam Deck. So we have Steam Deck here.
It's not.
It's what?
It's Asus.
Asus, okay, but it's the same. But the problem was that we didn't have any PSP related code. So we decided to start a little bit in advance. We started like a month in advance before the contest to develop some common parts. We don't call it a game engine because it's not an engine. It's a collection of libraries. It's a collection of utilities that we can use to build our game. But it means that you don't have to wonder how these guys were able to build that many things in 3 days. No, in 3 days we developed only a game, but we prepared for a month. Yeah, and again, this one was developed in the public GitHub repository. Feel free to have a look. Yeah, so. There was only one official way that people can develop for PSP, and it was tough. So only mid-size and big-size studios can go that path. And it was you first contact Sony and asking for a dev kit. You need to prove that your studio is capable of delivering the final product. Then you receive a dev kit, develop, and it was really hard back then. Then you go through a lot of Sony's reviews, then you publish your game. Bravo. but now there is no official way to develop for PSP. But soon after PSP was released, hackers started to find exploits in firmware to allow launching the unsigned code on the devices. And there was a very big and very strong community of hackers and developers who laid a very strong foundation for the homebrew movement. And actually, the idea of the whole homebrew is not piracy in the first place. It's more about the freedom. It's about research. It's about allowing users to use their purchased devices the way that they want to launch anything. So that's how it started. And now there is a very major ecosystem of SDKs, emulators, tools, libraries, that was built from this homebrew community. I will touch base on two main parts of this ecosystem, and the biggest one is PSP Dev. It's an open source SDK for PlayStation Portable development. And it's really mature. It covers a lot of functionality of PSP. So it has mostly everything that PSP is capable of. And PPSSPP. It's an open source PSP emulator, and it's ported to a lot of different platforms and can run any PSP game. Okay, now let's talk about PSP Dev. For our quite a small game, we require very few things. We need 2D renderer, we need audio output, and we need user input, right? And PSP Dev, of course, provides everything to cover our needs. So it has a graphic utility library. It's called GU, and the interface of GU is very similar to OpenGL. So of course, it can do also some 2D rendering. It has user audio library, which provides 8 channels of audio output. So you see a limitation of 8 channels. We will talk about it a little bit later again. And it also has the controller kernel library that covers reading the status of the controller. So looks like we have everything. And using PSP Dev directly provides a lot of flexibility, a lot of control. So we will be able to create another Burnout game. But that's a little bit overkill for us. And another point is that we wanted to have a safe net of having the host build. So for example, during the contest, something goes wrong. We have some really weird bug that we want to debug. And usually debugging something weird on a real hardware or on an emulator is a very painful task. So we wanted to have a safe net of host build. And it means that if we go that path of using PSP Dev directly, we will build at the top layer of interfaces, hide PSP Dev, implements something using OpenGL, OpenAL, and some controller logic. So it's a lot of work. And bing, there is something similar to that, right? Looks like SDL can cover all our needs, right? And we are lucky because SDL has a support, a native support of PSP. So PSP is one of the supported platforms on SDL. Let's talk about SDL. So SDL stands for Simple Direct Media Layer. So it's a cross-platform library that hides complexity of window management, simple 2D rendering, audio input and output, keyboard and mouse support, and many other things. So it looks like PSP SDL provides everything that we need for our Lududari game. So let's talk about 2D rendering, the capability of SDL. So it has some drawbacks actually. SDL's rendering primitives can be split into big groups. One is to render rectangles, like rectangles, real rectangles on screen. And the other group is to render polygons. They call it geometry. And unfortunately, SDL doesn't provide the ability to set the model metrics. So it's okay for when you render a rectangle because it has only 4 vertices, right? So you can build a rectangle to render here, you can build a rectangle to render there. But when you try to render geometry, it means that if you prepare geometry to render on this part of the screen, and you want to render it over there, so you need to update every single vertex of this geometry to a new place. And on PSP it's even worse because PSP renders very fast from VRAM and we store all our vertices, vertex buffers in RAM. So SDL copies them, and then starts a rendering process. So we need to update them twice. But actually it went quite well, because the majority of rendering in our game was with using the rectangles, and only rich text uses rendering of geometry. We start with using SDL2, and SDL2 provides a really nice way to output audio. It really nice. Well, let's say like that. So it provides a single channel audio output device, and also the huge library that mixes audio to give it to the output device. And we decided that we will implement our own mixture, because we don't want to have the low-level limitation of 8 tracks. So SDL's mixture can mix only 8 tracks. And I don't really like interface of the SDL's audio mixture, and because we can. And that's the main reason. And it's fun. So yeah, we have our own mixture, but we output to the SDL audio device. And the controller and joystick stuff was really straightforward. We just did some mapping from the keyboard to the PSP's control to be exactly the same as an emulator. So anyone who runs on host, we will have the same experience as other person who runs on emulator. Yeah. So everything is ready for Ludo Dare. So that's how our game looked like before the contest. So you see that's actually a demo of everything that we integrated into our engine. So here is the rich text support, and that's the only component that uses geometry rendering primitive in the engine. No, not the only one that on this demo. I will talk about Spine later. So there is audio mixture. We also used the texture packer. That's a very famous and very commonly used thing in 2D game development. So it packs sprite animations into bigger atlases, and then we created loader of this format and renderer of these animations and animation controller. Let's get back to rich text a bit. So there is a very commonly used format for bitmap fonts, and bitmap font is when for every character we store not a vector representation of this character, but rasterized bitmap, and usually they're packed into bigger atlases, and BBM font provides the lookup table that, okay, this symbol should be here in the bigger atlas. We use online tool that can convert TrueType fonts into BM fonts format. So it just renders TrueType fonts into the bigger atlas with the symbols that you want to provide. It's not the ideal solution in terms of memory, but it works quite well, because honestly I don't want to rasterize glyphs on a PSP. No, I think that it might be too hard. And yeah, the other component that we didn't use in our game, it's for 2D skeletal animation, and there is a really commonly used tool called Spine. It provides the interface for artists to create 2D skeletal animations that then you export into the Spine format, and they provide runtimes for different languages, and we use C++ runtime together with parts of the SDL runtime to load spine animations. So this guy, the trans, it's a spine animation. But we didn't use spine in the final game because our artist who can create spine animations didn't participate this time. Yeah, and now I will let Ivan to talk more about modern stuff.
Yeah, okay. I will continue sitting. Okay, so we called our talk retro game development with modern tools, and I want to explain a little more which tools we use it in this development. Dmitrii already mentioned SDL3, and we also use it Meson build system. It's quite modern tool, and GCC PSP Dev provide GCC, really recent one. So. Build system is really important, and PSP provide PSP Dev Kit, PSP Dev, provide make or CMake support, but these tools are well known and really flexible. You can do whatever you want using make or CMake. But usually people want to focus on development of game or application instead of writing this extra scripts. And because of it, we decided to use Meson. So it's now very popular, many open source projects moving to it, and I have used it before in my personal project, and we started it using it for Udum there as well. And benefits, yeah, it's easy to set up, and simple cross-compilation, support C, C++, and many other languages, works on everything, on Linux, Windows, macOS, and simple integration of test, formatters, linters, and whatever you want. And we use Meson a little differently. We utilize host target feature, which I believe mostly use it for building some building tools for cross compilation, but we use it to build host version of game in the same configuration as cross build to simplify our work. Yeah. And on example, you can see the simple build script for simple SDL application. So it's really simple. You don't need to do anything, almost anything. Only find your libraries and create a build. For cross compilation, we have PSP Dev. You need just specify compilators, linkers, and whatever you use, and cross build. So really simple. If you need to test, you just add your target, executable target to this test list, and then you can run them all using ninja test command. We enabled it in GitHub Actions, so it was, or code was partly tested on every pull request. So if you want to add C-Lang formatter or C-Lang TD, you just put your config files to the root of the project, and corresponding build targets created automatically. Then you can run the C-Lang format or C-Lang TD, whatever you want. And it helped us a lot to iterate fast, and it was really needed during this jam. We both use C++ in our work, and Dmitrii already had some game engine written in C, a lot of helpful utilities and libraries to build games. And of course, we didn't have questions which language we will use for development of this game. So PSP Dev provides quite a modern GCC version. It was 15.1.1, I believe, in the version which we took for development, and it supports C, C++, and we configured our build system to use C++20, of course, because we are using modern tools for game development. Actually, I checked what we used from C++20. It's only designated initializer, but it's good. Finally, we can just copy C code from from C to C++, and we used a new formatting library from C++ 20. Everything else, I believe, mostly C++ 11, 14.
Only these two features from C++. Wow. Very modern.
Yeah, and after 3 days of development, we published our game for as PSP image, so people can run it in simulator, emulator, and we didn't publish the host version of games, as Dmitrii already described it. Nobody likes to run some on-GNOME application on the laptops and host process. So we started looking how we can involve more people to run our game, because it's an important part of Jam. People should play games after they publish it. And we looked at WebAssembly, and we have learned that SDL3 supported out of the box, so we didn't have experience before with it, and we just followed the manual from SDL site and downloaded mscripting and added a new cross compilation, and it just worked. So of course it was some difficulty to inject all assets to this build. We need to fix main loop because in WebAssembly it works a little differently, but it's mostly straightforward. And everything described well in this manual. And yeah, and Meson helped us again a lot, because it was very simple just to add new configuration. So yeah, and finally we got this game in browser, the same game.
So it's a PSP game running like everywhere in browser on what's this Asus what?
Yeah, it's a Asus Sally.
Something on the Chinese with an emulator on real hardware on hosting emulator on host. So modern tools.
Yeah. So yeah, we're almost done.
Questions?
Why not CMake?
You have some questions?
Why not CMake? Well, that's more a question to Ivan.
Yeah.
But since he joined our, let's say, community, he decided to use Meson a lot, and actually I really like his contribution, because now we iterate really fast. So he usually builds the whole pipeline the way that you just run a single script and you compile, build resources, everything, blah blah blah, bam, your game on the emulator. So it helped us with a play date, because it has a simulator, right? It helped us very much with PSP. So single command, you launch your game on emulator. Can we achieve this with CMake? I don't know. Ivan can tell.
You could do the same with CMake.
Maybe.
But I mean, if you're used to using Meson, then
I don't use it, but I use it for my personal project.
makes sense.
But yeah, CMake for me it's too complicated to learn this thing, to write these crazy scripts for every.
You also need to script. And now we have
We script in Python. Usually we do some scripting. We just use Python, and it's much simpler for us to maintain it.
Yeah.
More questions? Oh, always the microphone.
Yeah. First thing, could we go to the beginning of the presentation again so we can scan the QR code?
Okay.
Yeah, and so here I also have another question, that being, we talked about PSP Homebrew, but how is it looking like developing things for other retro handhelds, you know, something like a Game Boy or even like a Nintendo 3DS, which is notoriously easy to hack, or maybe even something newer like a Switch? Is that possible?
I think that I saw the same thing as PSP there for Switch, but going down time, it will be much harder. So I think that for us, PSP is like a perfect middle ground. It's still retro. Well, it's not that retro, right? But it still kicks this nostalgic vibe, and we don't have to write everything in assembly. So it's perfect middle ground, as I said. Can it be achieved with a Game Boy? What do you think?
Sure. I believe we will not be able to use C++ mostly. Even if we would, it will be like a really small subset of C++, and we should think about memory, about everything. Here we didn't think about anything. We just wrote code C++, and it's enough memory for this small game, of course. Of course, if you want to implement something bigger and more complex, you need to do something.
Okay.
But good luck. Maybe next year you will be standing here and telling us about modern tools for Game Boy.
Not a software developer, so it's going to be hard, but who knows?
Who knows?
I actually ordered like a little emulation handheld. Let's see if I can figure something out with that.
Yeah, probably starting with the emulator is a good idea. Yeah. Good luck.
Thanks.
Yeah.
More questions?
Thank you.
It's about the first half where you say that the PSP has 8-channel sound support. You mean simultaneous, as in hardware mixing?
So I didn't dive very deep into how they mix it, but probably they utilize the DSP, and that's why this hard limitation of 8 channels. Yeah.
Because the question was going to be that I think SDL mixer is pure software, right? So
I think that on PSP, if we will use the PSP dev, it will be mostly hardware.
Okay, good.
But we implemented our mixer in software, so it runs on CPU, and that's why we decided to downsample it to 22 kilohertz. It's enough for games, and it provides a lot of performance. Why I don't want to have this limitation, because it usually leaks, right? So you cannot write your code like top level code without knowing this limitation, because you need to think, this sound should go into that group, and this sound should be probably pinned. We want just a simple interface, play.
Yeah.
So something very simple. So that's why I usually try to avoid limitations like that. But again, the main driver is we can. And
yes, I understand.
Yeah.
I'm actually looking for libraries that can do this mapping of. You forget about how many channels the host has, and like transparently maps whatever can be done in hardware, and then dynamically does what cannot be done in hardware in the CPU.
Yeah.
So if to use the 8 channels would have been a very good reason to me to roll down your own mixer library.
Yeah, but probably we can do something like that. But again, we most likely we will never hit this limitation of 8, right? But it means that it shouldn't be there at all, like this limitation, because if you have it, then you need to leak it up the stream, right, into the game code.
Yeah, I agree.
Yeah.
Thank you.
Helped us a lot with this software mixer, because when we tried to build a SDL WebAssembly version, we didn't check it because everything worked well. But the page of SDL3 support for WebAssembly mentions that it's only 1 channel in the mixer.
Actually, I thought SDL mixer was always software. So it seems
do you mean SDL mixer? I think that yes, it should be software, but we don't know how it maps to the PSP implementation. Because SDL, you know how SDL is implemented. It has like implementation files for every platform. So if you just implement the PSP part of the mixture differently, like utilizing these 8 channels, then it might be the hardware. But I was saying that PSP dev probably will give us hardware performance with the DSP. Yeah.
okay.
Yeah. But again, for us, even so, software mixture was more than enough.
The 120 FPS you were showing was on the PSP. At the beginning, it was
This 120 FPS was on PSP. PSP? Emulator? PSP emulator? Emulator probably. But on PSP it was mostly the same, so...
Thanks.
So you mentioned you decided to buy, building on your question actually, because I was curious about the sound system you made, because you mentioned you wanted not to use the SD while provide one. So about the features or the differences that the new system has in comparison to the provided one?
Well, of course, it will lack features, right? So we can only play wave format. We don't do upsampling, downsampling. So if we decide to use the 22 kilohertz, every sound should be 22 kilohertz, right? What else?
More than enough for the games, but
Yeah. But we also there is maybe only one feature that stands out is automatic streaming from the persistence storage. So we have two options. We can load WAV files into the memory and play from the main memory, and we can also stream from the persistent storage. And we do, for example, streaming for music, and everything else is just loaded in the memory.
Okay, perfect. Thanks.
Yeah. And also the main driver for me was I like groove boxes, and I was just curious how mixing is done. So we understand that it's a wave, right? If we sum up waves, then it can overshoot the headroom, right? How it's managed and stuff like that. So it was like a research project. Nice. Now I know a little bit of it. Yeah.
More questions? No. Go.
Thank you. I was just wondering, what kind of memory constraints you were working with, and if you faced them during development of the game, or everything just fit in memory?
Well, everything can fit into the memory except music, right? The PSP 1000 has a limitation of 16 megabytes of memory. 16, crazy. And the next generations are 32.
Yeah, that's pretty large, decently large. Thank you.
But the screen is very low res, so it helps a lot.
Yeah.
Yeah.
Well, thank you for all your questions, and
so we have a few devices. If you want to try, you can try.
Yeah, play the game here and give the presenters an applause.
Thank you.